Welcome to another webinar series, another chapter of webinar series. Today, if you don't know me before or you haven't seen any of our webinar series, I'm Francisco Piccolini, open source community manager at OpenNebula. We will be talking today about how to migrate from VMware to OpenNebula. But let me give you a quick introduction to what is OpenNebula and what we are doing right now. This is part of a webinar series. Actually, this screenshot is a little bit old, but just to give you an idea of how many. Sorry, a quick hiccup in the connection. I was saying that. I hope that this will be edited later. Uh, what I'm saying is that you not only have the webinar series, but also the training series right now, where we cover not only features and topics related to OpenNebula. You also will be able to learn how to operate in the basic operations with the one-on-one training sessions, and also with more advanced like multi-tenancy and Kubernetes. So please take a look on the series that we have in the web page, so you can subscribe and register for the upcoming webinars. But what is OpenNebula? Super quickly, we are a cloud virtualization platform. We manage and handle workloads, especially facilitating operations on any applications. We can run and deploy on any infrastructure, and we especially are oriented for VM, multi-services, and containers. So take a look of what we offer. The OpenNebula, like I say before, it can run and deploy on any infrastructure. We can handle and manage workloads, facilitating operations on any application, and it combines private, public, and edge cloud operations under a single control panel and an interoperable layer. The benefits, it's that obviously the power of simplicity, flexibility, being vendor neutral, easy to customize, easy to manage, with a nice interface that my colleague will be showing in a bit. But I don't want to waste much more of your time, but this is a little bit of an overview of which companies are using OpenNebula, from telco to fintech to academia to gaming to many areas, and they trust in OpenNebula because we can handle and manage this infrastructure in an effective and simple way. Moving aside from the commercial side and moving aside from the internet connection issues, the thing of the live events, I'm going to welcome my colleague, Alberto Picon, who will be explaining how to manage and operate OpenNebula to migrate from VMware.
Hello. I think your mic went gone. I think I'm not sure.
Anyways,
Hello.
thank you.
Okay, that's okay. So, hello. My name is Alberto Picon. I'm responsible of the technical support department and cloud deployment services in OpenNebula Systems. It's a pleasure for me to explain this awesome tool that we have developing since more around 9 months from now. It's an open source tool that OpenNebula has developed to ease up the migration from VMware to OpenNebula, and we will deal with a quick demo migrating a VMware a VM in VMware from VMware to OpenNebula. So if you can, let's move. What's OneSwap? OneSwap, it's an open source migration tool that was developed fully in OpenNebula, and it's based on B2B framework. It's a tool that we use internally to migrate VMs from vCenter to OpenNebula. As you know, OpenNebula has a long history supporting VMware interfacing with vCenter and VMware. So we developed this tool to set up this migration is publicly available. I will show from where you can download it and how to install it. But the main features you may found in this tool are the ones I exposed there. The functionalities are like automatic VM disk image conversion from vCenter to OpenNebula. It will create automatically the VM templates from vCenter to OpenNebula, obtaining all data and compute resources and disks from vCenter to OpenNebula, registering automatic this VM, these disk images, and will create the virtual NICs and assignments to the virtual networks automatically. You can tag the virtual machines that you want to convert in a very automatic way, and you can automate this using Ansible tools too. The contextualization packages are ready to use, and you can use this framework to inject this packaging inside of the converted VMs automatically and register them in OpenNebula just in one phase. All operating systems are supported, so you have Microsoft Windows, all operating system versions, and Linux, all these common OS operating systems like Red Hat, Alma Linux, or Ubuntu, or Debian. So what we are going to convert now? We will do this process. We have a vCenter running Windows Server 2022 VM, and we will use a OneSwap conversion VM that is running Ubuntu 24.04 LTS version. So the whole environment is already set up, and we'll convert the virtual machines from vCenter to OpenNebula front end, registering the disk and creating the template automatically as I show there. So if we can switch to my screen now, you will see that we have a virtual machine, a Windows 2022, and we will get inside and we will log in. Sorry. So now we are going to create a small file here. Lots of windows open all of a sudden. So we will create a small file. And the virtual machine must be powered off for the conversion to complete. So six. So we have this file, and what we will do now, it's just powering off the machine. I'll wait for the virtual machine to power off. Okay, so the OneSwap will connect to the vCenter. We can use several commands to interact with the vCenter and try to select which are the virtual machines that are available, which is the state, the host where they are running, and the resources they are consuming. For our purpose, for our demo, we will choose this one, this name, VM Windows 2022. And as you see here, this virtual machine is actually powered off, right? So what we need now is to execute the conversion process. So we'll explain later, because this process will take around 13 minutes to complete. So we will execute this. We will convert the virtual machine, providing the name and the endpoint of OpenNebula, the password we will use, and the user and the persistency of the image. And we will download the whole image locally to this conversion machine. And while this process is taking place, I will continue my explanation. So which are the requirements and what we have to configure for OneSwap to work. Uh, Ubuntu 2024.04 is recommended because we have already all these libraries right in place, ready to use. And of course, we need some additional packaging like libguest fast tools and MBD kit, because at the end, what it happens here during this process, the whole virtual machine will be downloaded locally, and we will mount in a CH root virtual file system as a way to inspect internally the disk we are downloading and to inject the packaging and the drivers in case of Windows or and the guest OS agents inside of the Windows machines, or install the guest OS guest agent for Linux operating systems, and the contextualization packages is if possible. So we have all these requirements here to work. So with the speed up the download process that we are doing right now here, we can use this BDDK library as a way to interact with the vCenter in a faster way, a more performant way. We cannot distribute this library, but you can download it directly, and there is a procedure for you to use and to enable the usage of this library in OneSwap. And additionally, we have all this process to follow in terms of converting more efficiently Windows guests, as we are doing now. All these setups have been already done in our configuration, of course, but we provide a detailed way to make this work in your own configurations. The contextualization packages, as I mentioned, will be fully installed and injected inside of a converted machine. And we can do, of course, different actions too. Of course, we can go in this way with preparation. So, what do we have to do in terms of assuring that our commission will be as successful as possible? In terms of Windows, or it's mostly covered. Mostly all problems related with Windows are related with network interfaces and how the Macs are translated. Mostly are fully supported, and the problems that we face maybe sometimes are the injection of the contextualization packages or the IP address assignments, but we haven't found problems related with these conversions. As far as it's possible, OneSwap will be able to inject the packages automatically from Windows Server 2012 onwards. It's fully compatible. So as you see here, we have already downloaded the whole image, and now we are inspecting the source, mounting the file system, and inspecting the whole image to know what kind of operating system is, and in base of that, we will take actions in accordance. For any kind of guest, we support the UEFI or BIOS firmware, and depending on that, we have to create the correspondent template and configure the template in accordance. But OneSwap will create the template for us automatically, and we can instruct all these settings inside of the OneSwap configuration. So it's pretty straightforward, and we can do it automatically in automated processes. There are some limitations, unfortunately, especially with Ubuntu and Debian, because it's not supported the group 2 update of the boot process. Sometimes it's not possible because our tool is based on B2V, and it's not compatible with group 2 update. We haven't seen many problems with this, but they can be repaired using system rescuecd or live recovery from Ubuntu as a way to fix the boot up process. It's inconvenient, but not something that can deliver unconvertible VMs. Okay. As I said, we have different ways to connect to the vCenter. We can use different transfer modes using the hybrid. What we'll do is we'll use a library to download the image and convert it locally, like we are doing right now. We can connect to the SSXI to transfer directly the image from the local file system of the hypervisor and transfer it using SSH. We can use the vCenter API directly. It depends on what we choose using the flags provided, but depending, we have to test this in terms of achieving the best performance transfer, network bandwidth, and performance conversion. It depends on your work on the load of vCenter, the network bandwidth you had available, and it requires some testing first. Okay. So at the end, what we need here is a way to provide the options, the correct options. We can provide the options directly using the command line, or we can choose the whole. We can select all these parameters and filters. We can set all these flags and use a configuration file that will have all this functionality available. And we can configure it directly using the configuration file. As you see, we have already detected that we are converting a Windows Server 2022 and is expecting the whole file system to know which are the free blocks and deduplicating the whole image to create the QCount2 file that will be used as a base to transfer it to OpenNebula and register it as an image. Okay. One of the things that we can instruct here is our different options related with the template we will create, like what kind of graphics type, the graphics memory, the persistency of the image, how much memory we will assign. We can specify this in a configuration file to avoid specifying this directly in the command line. As you see here, the configuration file, you can find it here in this file. And I will show it to you just a moment. So as you see here, we have all sorts of different configuration files here. At the end, we have the NIC configuration, the ID of the default network that we will attach our built-in machine or our converted machines, which is the format we will use. If we are going to install the QEMU agent on Linux by default, where the contextualization, where we will leave the contextualization files, what kind of the options in the template, for example, the CPU model or the graphics type. This is pretty important when you put up the image for the first time. And all these settings, you can set them up and use all these flags in the command line. So as you see here, we have found one disk and it's creating the final disk in that path. It's creating and inspecting the disk. Okay. Just a moment. And as you see here, we are expecting to see an image registered here. In the storage images, we will have the image that the disk image we are converting using this process, and we will find another template here that will point to this disk image. Okay. I have already prepared this template as a way to improve the experience and to boost up the boot up process and the performance of this virtual machine we are converting. At the moment, we have set up the host pass-through as a way to improve the performance of the virtual machine. And we have set up this configuration flags to speed up the boot up process and to improve the performance for Microsoft Windows environments. Especially these two, with the machine Q35 machine type and the CPU architecture as a way to improve the performance. So as you see here, the disk has been already inspected. The injection of the contextualization package for OpenNebula has been injected inside of the machine, inside of the disk image, and we are expecting to inject the disk image inside of the OpenNebula instance. What we are doing now is launching a very light HTTP server as a way to instruct OpenNebula to download it from this conversion virtual machine. So now it's proceeding to the upload process, and we will see something here. As you see here, we have a disk serialized with the number 0. So it's the 0, the first disk of the machine we are converting. And should be ready in maybe 1 minute or two. You see here too, system has checked that the system has a UEFI boot up process. So it will create a template based on UEFI and pointing to the correct firmware in the template for this to boot up correctly. And now when the whole image is already transferred, this image has been already created to point out to this storage, this disk in the data store. So we will boot up this image directly, okay? The disk is around 20 gigabytes of size, as you see. And the whole process has taken 30 minutes to complete. As you see here, we have a summary. We have created an image with an ID 119, and then we have a VM template created too, which is number 66. We'll check it here. So we have number 66, and the image is already in green, which is number 0. So we are going to boot up this one. It will take around 1 minute and 30 seconds around to copy the whole file image from images data store to the system data store. You see here is currently in prologue state, which means that it's transferring the image from the image default data store to the system data store. And when the whole copying process completes, the system will boot up. Something, as you see here, with B2B, we can point out where the library, the acceleration library to connect to the vCenter, we can specify where the library is. If we inject the QEMU agent inside of the virtual machine for Linux virtual machines, or for Windows, we can point it out to the correspondent ISO with the QEMU agent and the Veritio drivers, ISO virtual drivers, which are the paravirtualized for Windows, that covers storage, networking, and CPU overloading and memory resizing, hot block resizing. And some other tools we can use this flag to automate things, the conversion for virtuals for B2B. So let's have a look to this. Is it still copying? As you see here, we can specify the network ID and attach our virtual machines to the virtual network we choose. At the end, we can set up different virtual machines and create templates using this procedure. Okay. As I mentioned, we have different types of transfers depending on what it's available. It will use the hybrid by default, but we can choose different ones depending on our choices, the performance of our systems, and the performance of our vCenter and our network bandwidth. As you see here, the machine has already booted up, and it looks like it's booting up right now. So as you know, at this moment, the Windows machine is currently detecting all the hardware changes. Okay, looks good. As you see here, the IP address has been already assigned to this machine. Okay. And we will see in this in the desktop that we have the file we have created. So we need another reboot for the whole drivers to be detected, fully detected, and the whole machine to be set up correctly. But the whole process has been completed without much incidents. Okay. So let's switch to the presentation, please. Thank you. So we have some OneSwap success migration use cases for you to have a look to them. One of the most successful ones were performed by one of our customers, Anchor Technologies. They use OneSwap as a fundamental piece of their conversion process. They use StarkSwarm as an automation framework to automate the whole conversion process now, and they use a dedicated networking environment based on 10 gigabit, and they moved their VMware infrastructure based on iSCSI storage, SAN, and fiber channel. They migrated to NFS storage using OpenNebula and KVM hypervisors. The whole process was fully automated using StarkSwarm on one side and OneSwap as a conversion tool, and they migrated 2/3 of their workloads and in their data center, around 180 VMs, in a fully automated process without much human intervention. Their success ratio was around 96%, and these 4% that was not converted correctly were related with problems with network interfaces or applications that were running inside of the virtual machines, not due to the conversion itself. Okay, so as you see here, they face, of course, different the conversions of different operating systems, Windows and Linux. Mostly both types were they used 3 concurrent conversions, 2 concurrent migrations from using OneSwap, and the average sizes were 150 for VMs based on Microsoft Windows operating systems, and on Linux they were around 60 gigabytes per disk. They migrated a huge several disks for databases and Elasticsearch and log systems, one terabyte and a half. And the process was completed in a long process, but fully automated. Around 30 to 40, 60 minutes for the bigger ones, and 8 hours for this one. So what have in our roadmap related with OpenNebula itself, and a bit with OneSwap too. We are expecting for OpenNebula 7.0 for in April 2025. So we will try to cover all those features, amazing features, and I think they will unlock lots of the functionality gaps that we have already detected in OpenNebula. We are planning to provide VM and Commvault agents backup support from now, but we are expecting to provide VM and Commvault fully integrated with the Beam console and Commvault console, a native integration. So it's something we're currently heavily developing in OpenNebula. Additionally, we will provide the expected DRS, intelligent operation of cloud environments, and we are designing and developing with major manufacturers, SAM manufacturers, to integrate with them using us an iSCSI driver to interact with NetApp Pure Storage. We will cover cross-cluster data migrations, and specifically with this demo that we have shown now, we have received several requests from customers to support OVA, OVF import, automatic import to OpenNebula using this technology. So we're currently developing this, and we are expecting to release this for 7.02. VNC console functionality improvements that will deliver much closer VNC experience, usage experience as you will find in VMware environments. The Windows OS guest support will be improved too, as a way to ease up the conversion process and improve the performance too. And one of the things that I think will be a unique feature for OpenNebula will be the CPU ARM architecture support. I think it will be ready at the end of this month, but officially it will be released in OpenNebula 7.02. And of course, this automatic provisioning for hybrid cloud clusters that provides, so obviously, scalability and portability for multi-provider cloud edge continuum in different configurations. As you know, OpenNebula is enrolled in several European projects to provide compatibility and interoperability with different providers, CSPs in Europe. So we are hardly working with them as a way to provide scenarios and integration with these providers. So I hope that this demo has been useful for you. Do not hesitate to contact us. Of course, if you want to test this, we can provide you a POC, a proof of concept of OpenNebula, and provide you with the necessary tools for you to try the conversions in an easy way, providing you an OVA to use in your own environment, and connect your OpenNebula POC to test conversions and use it in your own infrastructure. Thank you so much for your attention.
Thank you for the presentation, Alberto. We will see people in 1 week, because next week we have the training sessions, basic operations, and in 2 weeks we have a managed AI from the webinar series. So thanks everyone for watching us. Stay until the end, and we'll hope to see you next time soon. Thanks. Have a nice day. Bye-bye.
Thank you so much. Bye.